Good afternoon, everyone. A very warm virtual welcome to you all from the, I suppose, not so sunny southeast today. Hope everyone is keeping well. My name is Colm Callery. I'm a member of the Southeast Region Committee. So on behalf of the Southeast Region Committee, delighted to welcome you to today's webinar, which is Irish Construction Materials and Industry Update from Roadstone. So also a very warm welcome to our speaker today, Tom Holden. Tom is a technical manager with Roadstone. And Tom is no stranger to the Southeast. He's been with us multiple occasions over the years, so it's great to have him back in the Southeast. And Tom always likes coming back. He's a very proud Ballyhale man, so good to have you, Tom. So before I hand over to Tom, I'll just give you a brief overview of the Southeast region and what we do, and just also a couple of upcoming events. So you can see just what's shared on the screen there, just the various regional branches. So the Southeast region, we cover Wexford, Waterford, South Tipperary, Kilkenny and Carlos. That's the old local authority areas. And then the role of the Southeast region is twofold. So obviously it's a focal point for engineers in the region, and we actually proactively encourage the continuous professional development of local members through delivery of various lectures, seminars, site visits, and then social networking events. And then just with regard to the upcoming events, we have another event next Tuesday. So again, another lunchtime event. It's a webinar, so it's on event management. And this one is by Amanda Richards of Wexford County Council, Health and Safety Events Officer, and she'll discuss engineering challenges regarding event management. And then also we have a social event this coming Friday. So it's a golf outing for any golfers out there. It's in Carlow Golf Club. So the tea is reserved between 12 and 1:30, and Barry Knowles is organising this one. So if you want to join, feel free. And it's bknowles@carlowcoco.ie. I'll just say a note that to get alerts regarding all our events in the Southeast, that you can join us on LinkedIn. And I'll just note that all events offer CPD hours, obviously excluding the golf, and it's an opportunity to network with fellow engineers. Also an opportunity to share, gain knowledge by giving a lecture or hosting, arranging a site visit. So if you're working on an interesting project and you want to share it with us, we'd be only too delighted to hear about it. And then it's a local support network of fellow engineers, and especially regarding the chartered engineer application process. And again, a national support network through Clyde Road. So again, back to today's lecture. Yeah, without further ado, I'll hand you over to Tom Holden, Technical Manager at Roadstone. Thank you.
Okay, Thomas Holden. I'm a National Technical Manager for Concrete Products with Roadstone. 30 years experience looking at concrete and concrete blocks and mortar. So Colin asked me to just give a quick run through what's happening with regard to standards across the main product range in Roadstone. So we'll just head into that. Let's see. There we go. Okay. The national standards have updated SR18, which is your aggregates for mortar. They've done a revision to that, and that was published back in 2021. This would bring mortar sand into line with the other aggregates for using concrete and mortars, and SR21, SR18. So I suppose it's gone from system 4 to 2+. So it has to be third-party certification on the production control and the test results. And it also set new limits on the total sulfur and acid soluble limits, as in SR18 and SR21. So less than 1% on the total sulfur and 0.2 on the acid soluble limits. And you need a photographer's report and assessment of the sand pit, as you do with the other standards. So it's just bringing the aggregates for mortar in line with the other standards. There's a systematic review of SR16 going on at the moment. It's ongoing. These 3 subcommittees were formed off the main committee, and the 3 subcommittees were looking at various aspects of SR16, and they're finished up now, and they'll be reporting back to the main committee, Aggregates for Concrete Committee, or the Aggregates Committee in the NSAI. And that'll probably be going out for public consultation in the next 2 to 3 months. The few updates that were recommended. The TII road pavements have made amendments to the unbound and hydraulically bound material, the 800 series. And those changes, I suppose, the clause 800 series, your 803s, 808s, 804s, have replaced with unbound granular material description. So you have an unbound granular material type A, AC, and AM. And where those materials will be used in road construction, adjacent the 803, 804, 806, road construction, 808, adjacent to cementitious material. So your backfill to structures to stop thomicide and that type of attack on the structure. So your oxidizable sulfate limit there. And then your 809 material, your backfill to metallic materials embedded in the road surface. Again, your oxidizable sulfates have a limit of 0.06% on that. And all of those materials can have 30% recycled material. So TII are allowing recycled material now in that set of materials, which is a big change. And generally concrete or blacktop would be the two recycled materials that are allowed in. Then they go a step further. So you have unbound granular material type B, BC, and BM. Again, 803, 804, 806, and the same materials again, but in this case, you can have 100% recycled material. So that's a very big step for getting, circular economy going and dropping the carbon content of a new project or that by allowing either 30% recycled or 100% recycled concrete in the 800 series materials. The asphalt, again, the TII have also made changes to the 900 series for your blacktop, changes to on-site testing requirements, the B-min in line with SR28, analytical pavement design methodology, use of product performance characteristics to design new pavements, uses data from Series 900 and Series 800 materials, may not suit all potential work. And you need to engage with your supplier to discuss using this methodology before you'd start into a project or start into doing a road design. Your local supplier, would have to be familiar with the method. Again, sustainability. We're developing an EPD for blacktop as we are for concrete and aggregates. We have concrete block paving, our Roadstone thermal light block, and the standard block produced in Belgard with EPDs for those. And like that, EPDs are becoming popular in blacktop. The use of reclaimed asphalt, wrap, warm mix. There's huge focus on this whole area going forward in your design of roads and design of materials going down. And there's a version of the BS 594987, the IS 844, and that's due to be published in 23. So that's probably gone through all the stages in the NSAI and is ready for publication. Concrete, this is the one that I suppose there's a lot of changes coming down the road with EN 206, a revision to that. It won't be here for a couple of years yet, but when it comes, it's probably going to make a lot of changes. They're going to split the EN 206 into two parts. Part one will cover performance requirements to factory production control, conformity criteria, and then part two will cover conformity assessment, inspection, and certification. Main reason for the division of the standard into two documents is allow the concrete to be specified in part one and conformity in part two. But the content's going to say the same. It's kind of, we'll call it changes for the sake of change and split the standard up. Your lower strengths are going to have, the FC for the 10, 15, 20 Newton. You're going to have 1, 2, and 3 your FCK low strength rule. So, you get a 9 Newton result on a 10N as long as you have a few 11s in that. Your minimum strength on a 10 Newton, 15 Newton will be -1, 2, and 3 respectively. And that's to match the EN 13791 requirements. And then it's going to say the same for strengths. You get into your structural classes, 25 Newton and above, your FCK -4 rule is retained. The neutrality principle, again, your scope and your policy background on those two bits. For conformity assessment activities, including testing, inspection, evaluation, your auditing, assessment, declaration, certification, accreditation, peer assessment, validation, and your scope and your policy background. Then for your assessment neutrality system, which required documents shall be written in a way that everyone can understand them in simple terms, that all people involved in the standard or in the works would understand what the specification is about. Conformity assessment. The current revision of the interest revised with sampling classes replacing in terms of concrete. The assessment of concrete with certification and without certification. The sampling rules are different for both. Now here in Ireland, every concrete producer is certified to EN 206. So you can't really supply concrete to any project unless you're certified. So I don't know where the plant without production control would be that you'd need extra testing here in Ireland. Possibly if you're set up a site batching and you hadn't it certified, you'd apply the sampling rules for without production control. Clause 10, evaluation conformity, has been removed, which, it's a little bit mad in my opinion, and I'm half delighted that, again, this thing goes out for public consultation and, we draft up a new national annex to it that I'll be getting very close to retirement, because I think some of the decisions they're making in the new standards is a little bit nutty, but there you go. And the identity testing has been removed. Criteria for the mean result, and it is the responsibility of the first, second, and third party. So your supplier, your designer, your end user are going to have to agree on what level of identity testing would be required on site. The requirement that the 2 cubes are made and you take the average, that's been removed. And the requirement, the 15% rule between the 2 cubes. So if somebody makes 2 cubes and it's 35 Newton and one comes in at 20 and the other one comes in at 40, that's 15, more than 15% between the two, you disregard the cubes or you disregard the lowest cube. But that now rule is gone. So I suppose the simplest thing there would be just make 1 cube. You don't need to. But from a supplier's point of view, if site-made cubes are always a problem, and with no cube bats, and we go out and see horrific things on site, and guys basing their compliance on what we see on site, and the tea hut, the cubes thrown in the corner and no cube bat, and if this rule is gone, it's going to just make life difficult for everyone. A bad result, a poor result from a poorly made cube just causes hassle for everyone when it's reported. Again, just to repeat what we said, that's criteria for mean result, your +4. That's the same, and your 1.4 times standard deviation is the same. Okay, your new classes of durability classes are also being proposed, where you would have exposure resistant classes. Eurocode 2, so your current approach in Ireland is supposed to retain for a while, but there's 3 methods of specifying coming at us: your exposure resistant class performance based, you have your exposure resistant class by limiting values, and you're deemed to satisfy limiting values. So in Ireland, we have our durability table based on limiting values, and your holy trinity of minimum cement, strength, class, and water cement ratio, and then you add in cover on that as our limiting values. But if you're going performance based or deemed to satisfy limiting values, I don't know how or we're going to all agree on those limits. It's very simple at the moment. Everyone working off the tables in EN 26, the National Annex, and we work into limiting values. But this will only be for your carbonation and your chloride classes, freeze thaw, and sulfate resistance will be still based on your limiting values. But performance based, we'll say for carbonation, all the stakeholders have your concrete producer, your main contractor, your subcontractor pumping the concrete, another subcontractor placing the concrete, another subcontractor putting up the shutters. He'll want to take them down, strike him at the 14 hours. And does he cure the concrete, or what happens to concrete when it's stripped? And we're basing the carbonation on performance based from laboratory test results, probably done in by academics in a college. Not that there's anything wrong with that most of the time, but all your stakeholders, and bang, if you don't get the carbonation requirement and the steel starts to corrode before your design life, out of all the stakeholders, who's going to be blamed and who's going to be still standing? You're probably not going to get several of the subcontractors, the guy who wet up the concrete to pump it, or the guy who placed it and didn't vibrate it properly, the curing of the concrete, like what broke down, and you've based your design life on exposure resistant class. Anyway, that's all coming at us in the next few years, and it'll be exciting times. Probably the cost of doing your ERC will probably restrict it to large and prestigious projects where they're looking for very large amounts of carbon reduction and cement content, and they'll have the budget to do all of the testing required for performance-based testing. And then, if we're doing it by limiting values, I would imagine the limiting values we have in our durability tables in the N206 have stood as well, and we get very little problems with durability in Ireland. So I would imagine that will probably, hopefully, will remain the primary method. And then to deem to satisfy, again, who's going to sign off on the deem to satisfy limiting values? It sounds a little bit lean as a method. If you have an assigned certifier on site who didn't design it, and you have the design engineer, and who's going to sign off on the design, or who's going to sign off on the thing at the end of the day, if you're just working to deem to satisfy. So, as I say, exciting times coming at us if all this comes to being. Anyway, we'll move on to a bit on stone and a bit on blacktop, a bit on concrete. We'll move on to blocks, and as I'm the technical manager for concrete products, this is where I suppose the remainder of this presentation will hone in on blocks. So back last year in April, Department of Housing and Local Government published a guide to the marketing and use of aggregate concrete blocks to EN 771 Part 3 in Ireland. So the background of this document is that the department and felt that blocks, due to problems that were happening around the country, mainly in the northwest, needed a bit of scrutiny. So they set up a market surveillance team, and I have a couple of slides on it. So market surveillance was set up probably to go to 3 years ago. They started to audit block manufacturers, didn't find a whole lot wrong with the block production as such, but they did find that the DOP and the CE mark for the product were varied across the country and have a lot of not discrepancies as such, but they weren't uniform document, or they weren't the same document, and the layout of a declaration of performance is set in Europe in a certain way, and certain numbering systems and information that has to be declared. So the market surveillance came back to the department, reported this, and the department then published this document, put it together. So it's a very useful document, goes through a lot of information for everybody, all parties. So your standard here is 771 Part 3. That's your specification for concrete blocks, and that was amended in 2015. The introduction of aggregate concrete blocks within the scope of 771 must have a declaration of performance and a CE mark, and that's in place since July of 2013 when BCAR came in. So we adopted the construction products regulations back in 2011, 12, 13 is when they were made law. So every block producer in Ireland must produce a declaration of performance and the CE mark as a separate document, and that should have been happening since 2013. Was happening, but the documents weren't to the proper layout and displaying exactly the right information. So here's the information on the CPR. So as I said, regulation came into being in 2011, and that sets out everybody's responsibilities and the rules. So regardless where the products are manufactured, in Ireland, EU member states, Northern Ireland, Great Britain, or other third parties. And that's not just for concrete blocks, that's for all construction materials. And as I say, it was adopted fully into Irish law July 2013. So 9 years later, a clarification on what a concrete block should be and what it should be supplied to was printed by the department. So within the document, to use a very useful table, and it kind of sets out the summary of obligations of, who has to do what for concrete blocks. So you see in brown, the manufacturer putting the block on the market has to make it a harmonized human standard, is responsible for the assessment and verification and consistency of performance, and European assessment document voluntary. And out of that, the declaration of performance and the CE mark has to be available. And it's the job of market surveillance to make sure that the manufacturer is doing all of those things. And then the block goes to site, and it should be built to the building regulations. Workmanship, materials fit for purpose, conditions of use, proper installation, and compliance with the building regulations. So they're all the responsibility of the owner, the builder, the specifier, designer, and certifier. The manufacturer is responsible for producing the block and declaring its properties to the standard. So if you're a manufacturer, an importer, or a distributor of the material, you're responsible for making the block to the standard, declaring the performance, and having a CE mark available. And enforcement of production is market surveillance, and enforcement of doing all the rest of the things is building control. So that sets out the obligations very clearly for everyone. Now, what's kind of new in this is take into consideration national provisions. So I'll just go through that, the construction of a dock, where all the various bits and pieces come from, and taking into consideration national provisions. So this is kind of new, and national provisions weren't being declared on the declaration of performance. So again, national provisions, this is just a description of it, so standard recommendations, and they set out appropriate minimum performance levels, and they're known as national provisions, and they can be found in guidance documents, technical guidance documents to the building regulations. So the majority are set out there, and they refer you to the Eurocode, and they refer you to SR 325. They give minimum densities of block for sound, durability requirements in part C and D. So we have a lot of national provisions, and they can all be found and traced from building regulations, technical guidance documents, out to the SRs, out to the ENs and codes of practice, and they're all there and should be used. So again, SR 325 is very important. There's a lot of information in SR 325. And again, SR 325 and Part A, the building regulations, state that the blocks in Ireland should be Category 1, which means that you're third-party certified to produce blocks. So a notified body, the NSCI is one notified body, SLR is another. There's probably 2 or 3 notified bodies working in Ireland. Roadstone tend to predominantly use the National Standards Authority of Ireland, but you can't produce blocks in Ireland compliant with the building regulations unless you're certified to do so by a third party. Aggregate concrete blocks intended to be used in elements, structural requirements are required to meet the prescribed performances set out in SR 325. So density, compressive strength, moisture movement are the 3 that are in SR 325. The mortar classes are there. Achieve appropriate durability for finished work in Ireland, that's set out in 325 as well. And the aggregate used in the blocks has to be compliant and certified to 12620 aggregates for concrete and the national provision set out in SR 16. Again, you have to be certified to make the blocks, and you have to produce the blocks with certified material. So your sulfate levels and your magnesium sulfate soundness test and your hardness test, they're all set out and all provided as national provisions within the SR 16. So the declaration of performance, again, essential characteristics shall be declared, and that information on the DOP and CE mark must be made available on the market. Where national provisions do not exist for certain essential characteristics, or where some characteristics are not relevant to the intended use of the product, the manufacturer may decide not to declare a specific performance. So in both cases, no performance determined NPD may be used and put on the declaration of performance. Now, when you go through the national provisions, there's very few of the requirements in Annex A of the standard that we can use a non-performance declared NPD on the DOP, and I don't think I have any NPDs on the block DOP in Roadstone because we can match all the criteria back to a national provision. So Annex A, here we go. This is where we go to find out what has to be done. So dimensions, tolerances, configuration, declared, you're into compressive strength, moisture movement, shear bond, flexural bond strength, reaction to fire, your classification, water absorption, capillary, water vapor. Now you see here, I have in red, not to be left exposed. This was what was used rather than no performance determined, just not to be left exposed, was used in the durability classes, we'll say, for the block. But the department, when their guidance, say, want us to use provisions here. Interestingly, the water absorption capillary has no value as such. It's not used in any design in Ireland, predominantly be used for external elements with exposed face that water may penetrate into the cavity, or it may make the unit's face susceptible to frost damage through spalling. But there's no minimum declared value on the grams per meter squared per second, which is the value that is reported. So there's no minimum value, maximum value, or any reference to that value anywhere in standards or codes of practice that I can locate. So we have to declare the value, but the value is of no practical use. So density, thermal properties, durability, and dangerous substances. Again, durability. There is no test for durability for frost damage or durability testing. So the not to be left exposed was used, but when you go looking at national parameters and provisions, you can find durability requirements built into the building regs and SR 325. So the preference of the department and market surveillance is that these would now be declared on the DOP. So there's a new layout of the DOP. The numbering system is as per the European guidelines, and the intended use is very clear, and the terminology common masonry unit is defined in the standard EN 771 part 3, as common unit is used with no face going to be left exposed. It's a common block, should be rendered, and that's the definition that you would use. So for fine texture blocks, they're going to be left exposed, or air leakage control blocks, they're going to be left exposed. They would not be described as common masonry units. They'd be facing unit, or in masonry's case, a masonry, exposed masonry that can be left exposed. So the definitions are as per EN 771 part 3. So that's very clear intended use, and that was a requirement again of the department and building control or market surveillance, that we would have a clear intended use for the product. And then once you get into the DOP itself, the table of requirements, you see here where the document has now a lot more information on it, and the national provisions and the performance are all set out, a lot more detail on the DOP. I think I've blown that up, yes. So the standards, block is to be designed to, the conditions of use, exposure class, the density, the mortar strength class, again, the difference between 7 Newton and 13 Newton blocks. All the blocks should be produced at aggregates complying with 12620 and SR 16. And then we copy that on the column on. We give the definition of the exposure classes, what they are, and that's all coming from SR 325, and it states where it comes from. The render code of practice, where you're going to get the render mixes, how many coats you need, your ability there, and the effects of freezing. So all that is copied from SR 325 and the code of practice for application of render. So these are all what's now known as national provisions, and we've been requested by the guidelines documents to start declaring these on the declaration of performance, that people know what a block is and where the block can actually be used and where it should be used. And then moving on to your moisture movement figure there, that's taken from the standard. Your reaction to fire, class A1, that's taken from the Eurocode 6 1996 part 1-2, and the classification is taken based on the European Commission decision that there's no organics. So you have less than 1% organics in the block cannot burn. So concrete block, you know, we can stick the Class A1 rating on it because it's in line with the requirements of the SR16. There's no organic material in there, so therefore it cannot burn. So again, the doc now is a lot more information on it. No performance determined is gone, and the national provisions are now being declared on the declaration of performance. And then that's all repeated on the document with the CE mark. So you have two separate documents. You have the declaration of performance that has a lot of information on it, and then that's summarized on a CE mark with the information and the CE stamp on it. Again, same amount of information, but it's a lot more toned down and the amount of it that's there. But still, and the information on what the block is and where it can be used is on the CE mark. So national defined parameters, national defined perimeters, revisions, where do they all come from? Dimensions are set. So your tolerances are set on the standard. So your D1, D2, D3. Now, invariably, most blocks in Ireland are set to D1, dropper blocks. Fine texture blocks, masonry blocks could be +1, -3, but that's very tight, kind of 214 ±2. The old IS20 standard had your ±3 for fine texture. ±2 is a little bit difficult to achieve. Some manufacturers will declare D1 with tighter tolerances as you're allowed. Some manufacturers will declare the D2. Geometry of the block, this is taken from the Eurocode 1996 part 1. There's a table in there, table 3.1. So it gives your classification for group 1, what it has to be, divides it can have, vertical holes, whether or not it can. Then group 2 is your cavity block, and group 4 is your horizontal hollow. We have stopped producing the horizontal hollow because I cannot make it fit on the DOP anymore, because it is not covered in the building regulations, the technical guidance documents, or the Eurocode, you know, the Irish version of that. So I cannot fill in national defined provisions or parameters for the group 4 block. So we've kind of decided we would stop producing the group 4 block. Density requirement, density 1900 kgs, minimum block weight around 1800 kgs. That comes from your Part L or Part E sound. So it has minimum density 1900 kgs. So I suppose for handiness and for not having 2 or 3 blocks in the yard, medium density blocks down around the 1500. Majority blocks now in Ireland are greater than or equal to 1900 kgs density, so that they all meet the requirements of Part E sound, and there's no mix-ups on sites or inadequate party walls and dividing walls being built. They will all meet the Part E sound requirement. So you have your details there, how to use the block in Part E. So that's where the 1900 comes from. Part A, structure. So dense and lightweight aggregate blocks, minimum thickness 90, group 1 masonry. So the specification for the block comes from Part A, your building regulations, your strength classification, and how it's to be crushed, air dry mortar capped. And the declared compressive strength probability of not exceeding 5%. So that's equal to 95% confidence. So block manufacturer making a 7.5 Newton block has to run statistics on that block now and prove that he's getting 95% confidence in the block. Can be mean or characteristic value, but the Irish National Annex to Eurocode 6 works off a mean value rather than characteristic, and it's level 2 plus third-party certification. There's guidance on how to calculate your 95% confidence given in a SEN document, SG10. You have to run full statistical analysis on your production. There is a simplified conservative approach for small producers, but the third-party certifier likes to see the same guidance. It's not too hard to run the 95% confidence once you run an Excel sheet together and the guidance is there on how to construct a sheet. That's an image kind of what the guidance gives. So you have your block tests, 6 tests, works out your XM, your number of blocks, your averages are there, and works over to your standard deviation, and then your estimated strength. And your estimated strength is the strength of the block with 95% confidence. And that always above your instance. Example, declared value is 15. You see there, all the blocks are above. Once you run the statistical analysis on the result, there are 95% confidence on all the blocks there. Old and new strengths, we probably all know this now, and we still get guys looking specifications every few weeks coming in looking for 5 Newton and 10 Newton, 15, 20. The old strength classes, those are as the new strengths, 7.5, 13, 18, 24, 36. Again, 36 Newtons at 95% confidence is coming out near 40 Newtons, and it's getting impossible to run, make a block that's 40 Newtons. So we're probably, we've made the decision to stop producing 36 Newton, and we'll probably declare a 30 Newton strength going forward. Very small sales of 36 Newton blocks anyway, but they were difficult to make when it was just an old 30. Making a 36 Newton is difficult, and then having 95% confidence that you were always going to have a 36 Newton or 80% of a 36 Newton is just driving that strength up near 40 Newton. So for 100 mil solid, it's proving very difficult to comply. So as I say, that 36 is probably going to disappear. Well, going to disappear in Roadstone anyway. Or probably replaced with a 30. So designers just take note of that. Your part L densities, so your lambda value comes tabulated out of 1745. So see here, your 1900 density will have your dense and light aggregate concrete units. So you're normally in this range here. 90% fractile of 1.09 would be your lambda value. 1.19 on 2000 density. So the lambda value declared is in this range here. It used to be 1.33, which would give you a density of 2100, but at a density of 1900, it's in the 1.09 lambda. So your lambda by your thickness gives you your resistance, or resistance inverted over 1 gives you your U value. Durability, and this is a direct clause out of 771 part 3, where relevant to the use in which the units put in the market, the manufacturer shall evaluate and declare the freeze thaw resistance of the units by reference provisions valid in the intended place of use. So until an appropriate European standard is available, but unfortunately there is no European standard available to do freeze thaw testing on a block. There is one for a clay brick, and I would use the clay brick one for testing exposed masonry, like our Fortcrete range, our Hunstown brick range, Hallmark and Keltstone would all be designed to be left exposed, and I would do the 100 freeze thaw cycles down to -20 as per the clay brick standard. But that's not, there is no standard specifically for concrete block. The Irish Concrete Federation and Technical University Dublin, Bolton Street, are running tests at the moment, trying to develop a test method, and that will probably be presented in NSCI going forward as the national test method for freeze thaw and an ordinary common concrete block. And then the note, and noted I used the terminology common block in my intended use for standard block. So when intended use of a product provides a complete protection against water penetration, suitable layer of render, cladding, inner leaf, cavity, no reference to freeze thaw resistance is required. So a common block is declared, no face left to be exposed. You don't need to have a durability class against freeze thaw for that block because it is assumed it would never get saturated and therefore wouldn't be subjected to saturation with freezing. But there's a debate on about that at the moment, and the use of the 13 Newton block in those situations, and when and if you have to have more protection, and will your render break down over time, and is the wind-driven rain increasing with climate change? And that's all out there for common debate at the moment. And the masonry panel is looking at revising table 14 of SR 325 in line with a new metrology map that's been published also, that I'll cover in a few minutes. Again, so this all comes from Eurocode 6 design, and SR 325 references the 326, and we go into the durability tables then that are in SR 325. So here's an example. We have our A1, A2, and A3, and that brings in your European classes of the MX. So low risk of saturation, MX 2.1 and MX 2.2 without freezing. Low risk of saturation with freezing. High risk of saturation, but the blocks are not going to freeze. And then A3 is high risk of saturation with freezing, MX 3.2. So the A1, an ordinary 7.5 Newton block. In M4, you go to A2, you increase the mortar, but the block still says 7.5 Newton. You go to A3, it recommends the use of a 13 Newton block and puts the mortar strength right up to M12. And that's out for debate at the moment, and lots of chat on it. And another engineering body recently published guidelines recommending the use of a 13 Newton block in areas of saturation with freezing. And if you can't rely on the render, the block is going to get wet, so it's going to get saturated and going to freeze. So as I say, that's topical at the moment, but that's where your national provisions are for durability against freeze thaw. It's based on concrete block strength and the exposure classifications that are in Eurocode 1. And I would think 1996 Part 2 would also have those classifications. Eurocode 1 would have the frost map, and SR 325 has the wind-driven rain map. So high risk of saturation with freezing, again, your strengthened block, and it says that that should be used kind of in the footings above and below the footpath, where it's likely to get saturated. You should stick in a 13 Newton block to protect the plinth from damage. And then another, I suppose, national provision, like for durability of the block, is the blocks would comply, the aggregates used in the block would comply fully with SR 16 and would have a magnesium sulfate soundness for durability value of less than 25. So this is where the provisions come from for durability. The Eurocode SR 325, and then the aggregates are sound and not susceptible to frost damage. So again, the aggregates for concrete SR 16, advice on that: dense aggregate greater than 2000 kg per meter cubed. And in the scope of that document, back in 2016, it was amended to include concrete blocks, so concrete masonry units, e.g. blocks, precast paving, precast concrete products, pavements, roads. But just because it's not concrete to EN 206, the SR16 was amended to include all that the aggregates used in concrete products and concrete anything should comply with SR16. A bit of a loophole there that some people said, oh, you don't need to use concrete, aggregates complying with 12620 in other products that are not covered by EN 206. But as I say, the standard was amended in 2016 to make it clear that anything that's called concrete should have aggregates complying with aggregates for concrete. And then these are the properties set down in SR16. So you have your LA of 20, you have your flakiness, you have your fines contents, you have your magnesium sulfate value, and your chloride and your acid soluble and total sulfur contents are all set down in your SR16. And at the aggregates then, geological assessment by a professional geologist, we use SLR, and we have to visit the quarries. Some quarries are visited monthly, some are visited annually. It's all dependent on the volume of aggregates we extract from a quarry or a sand pit. As I say, some of the busier locations are visited monthly, other places will be done annually, but they'd all be visited annually by a professional geologist, and they would declare, carry out the chemical testing, do visual analysis, and declare that the products produced in that quarry or sand pit are suitable for use in concrete. So I get asked this question a lot and send out a letter that you've got no deleterious materials in your aggregates, but we can't have deleterious materials in our aggregates because they have to comply and tested for all the requirements of SR16, 12620, and then the professional geologist has to have his survey done and his chemical analysis done and do a declaration of performance for the producer that the aggregates are suitable for use in concrete products. So durability of the block, presence of applied external render and finishes, quality of workmanship, seasonal types, masonry unit, mortar composition, joint finish and profile, thickness of inner leaf, and thickness of the leaf, in general, the outside leaf. So these all play a part in the durability of the block. And again, the information on all of these can be found in SR325. The guidance on these was all there. Thicknesses, 3-coat renders, 2-coat renders, use of single coat renders, type of masonry unit, whether it's strong, the mortar, if you have exposed masonry or joint profile, your tooled finishes. The raked out joint isn't recommended for brickwork in Ireland because of wind-driven rain and droplets of water sitting on the joint and blowing in across the joint. So that's all minimum leaf thickness, 90 mil. These are all national provisions and they're all in the standards and should all be followed. Durability, presence of the cavity, the weight of the airspace within the cavity, recommended of a 40 mil airspace for recirculation and keeping that outside leaf dry. So the use of full fill insulation, is that covered by SR325 and the Irish building regulations? Architectural features to keep the wall dry, overhangs, the type of wall tie, wall ties per meter squared. You see diagrams, wall ties, you need extra wall ties up openings, you need extra wall ties along your gable and out on site at times, and I don't see a whole lot of these extra wall ties being put in at openings or at gables. You might be lucky to get the 4 wall ties per meter squared, but the extra wall ties and the type of wall tie used, the wall ties in Ireland are to an old Irish standard. you know, there's some imported wall ties coming in, and I'm not too sure that they would all comply with the Irish provision set down for the wall ties. Water absorbency, generally less than 20 or 25, but there's no limits on this set anywhere. Again, the guidance in the Annex ZA said not to be left exposed, not to be used as a DPM. You know, in Ireland, we don't have any clay or tile or masonry product that you would use as a DPM as such, so there's always a proprietary DPM put in. This property is not required by Irish 20 or the Irish building regulations. As I say, it is used some places, but I cannot find a value for water absorbency that's meaningful for use in Ireland when applied to Irish conditions. But again, we've been required by the guidance document to do this test and declare the value. Moisture movement, again, this is a national fine parameter, so 0.6 of a millimeter per meter. Expansion or shrinkage in the table, 0.6. This used to be 0.6% in IS 20, so you work out millimeters per meter, it's the same value, but the test in Irish 20 was drying shrinkage. So that's a new value. I'm just looking at my clock. This presentation is going on a bit longer. I better start moving it. So moisture movement, again, that's our 325 moisture movement. Guidance on that, not greater than 7 meter centers. Again, national site provision. Use of movement joints should be designed in. I go to too many properties, too many houses, cracks in them. You walk around the property, no movement joints. They're very easy to design in and can be hidden with coloured mastic and nice bead there. So movement joints are essential and should be used. Here's an example of a pier restraint, 2 cracks down either side of it. Could be very easy to put in a joint there by putting the bead all the way down to footpath level, but wasn't designed in, and lovely cracks. Water vapor permeability, this is not a requirement, not including IS 20, but it is declared, and it's a declared value, tabulated value from 1745. Reaction to fire, again, I covered this, you know, need for test because there's 1% homogeneous distributed organic material. So you don't need to test, just stick the A1 class on it and you take your fire ratings from the 996 part 1-2. So there's 3 tables in there, 3.1, 3.2, 3.6. So separating non-load bearing, separating load bearing, and each leaf of separating load bearing cavity wall. So that's where we take our fire ratings for the wall from. The blocks generally have A1 classification, but the fire rating of the wall comes from 996 part 1-2. And very simple to use. Go into the tables, you have your minutes across the top, you have your wall thickness and your aggregate, your block type. So you follow the cross, go up your 240 minutes. Concrete doesn't burn anyway, so ability to continue carry loads, insulation, heat and fire, ability to prevent fire spread through the structure are all excellent. Shear bond strength, again, that's another tabulated value, and quote from the standard test for 325, properly bonded and solidly put together with mortar comply with relevant requirements of standard. Additional guidance given in SR 325. Dangerous substances, none. So because all the materials are controlled by their relevant standard, there are no dangerous materials use. No use of recycled materials as such at the moment, but again, that's changing possibly with the revision, the systematic review of SR 16. And again, everything is certified and market surveillance on the construction products. The wall, that's the definition of the wall. We go through it, what's required by the wall in SR 325, stability, materials, accommodation, movement, adhesion, resistance to movement, penetration, durability, fire, masonry bond, bedding, workmanship, and then other considerations: applied facing, weight of the wall, thickness of the wall, speed of construction, accuracy of construction. Renders, again, wind-driven rain. We used to have these classifications. We now have a new map, and this map was only published last year. And we see here where we had severe exposure now is gone up to extreme in the dark blue. So again, the revision of 325 is going to take this map into consideration and work on whether or not we need newer conditions or newer provisions based on the extreme weather we are now getting along the west coast, or is it extreme in name and still the same as severe? But with climate change, it probably has gone up a notch or two. But this is the new map versus the old map. External walls should, technical guidance part C, resist penetration, rain, snow for inside the building, not be damaged by rain or snow, not carry rain or snow to any part of the building, which could be damaged by it. So the wall is part of the building. We have to protect the wall from damage by the weather. And then part D, resistant to moisture again, condensation, so your 40 mil airspace to let the wall dry out. Prevent the passage of moisture to the material, or the material should be treated or otherwise protected from moisture. So does your render work to protect the block? And again, these are requirements of part C and D of the building regulations. There we go. Where does fulfill fit into C and D? Design preparation application of the render should be to this standard, and your coat thickness is in 325. Your number of coats, coat thickness is all traced back and back to your durability map and your wind-driven rain and how wet the wall is going to get. So they're all there. You know, your first coat, second coat, final coat, whether you use 2 coat or 3 coats, depending on the durability. And your 2 and 3 coat finishes. And again, prescribed mixes gives you your mix design for the renders. Prescribed mixes, no design mixes. So you're buying bag mortars or bag renders, you should check and see are they designed or prescribed and who's going to sign off them once they're designed and they don't meet these proportions. Mortars are 998, and again, gives your texture of mortars. Again, masonry mortar. These are your mortars used in build. Again, prescribed mixes. Your M4 is your old 116 recipe. None of what I showed today is new. It's all been covered and can be traced back to the old standards, or the majority of it can. We had IS 20 from 74. Irish 5 is there since 74. 325 is there since 86. Part 2 is there since 95. And before that, we were referenced out to 5262. These are again BRE Digest is from 71, 5262, 76, 91. So there's always been standards there, and they've all covered this. And just to prove it, this here I think goes back to 71. So your wind-driven rain and that dark grey and your 10 out here is still, you overlay that map on the new map, and all that west coast of Ireland is still in your severe category for wind-driven rain and should have been taken into account in design. EPDs are coming popular, and we have set out to get EPDs on all our products, and we have, I suppose, 3 of them done. So we have thermal light block, paving, and our concrete standard block done. So that's it.